Hello classes, this is Mr. Holmes. Today we're going to be going back to some algebra skills to help you get ready for Algebra 2 in the next year. We finished up our geometry, so we're done with that. So today we're going to be talking about solving linear equations, solving equations with variables on both sides, and solving inequalities with one solution. So we're going to be doing 3 sections all at once. We're going to start with solving linear equations. So solving linear equation, remember we must use PEMDAS, parentheses, exponents, multiplication, division, addition, and subtraction. But remember with multiplication, division, and addition, subtraction, you do, which one comes first? So if you see a division before multiplication, you do the division first. If you see the times before the division, you do that first. Same with addition, subtraction. Addition, you don't do always before subtraction, whichever one comes first. So that's PEMDAS. You should know that. So we're going to look at an equation, 4 plus 3x minus 1 over 2 equals 9. And I'm going to show you 2 methods how to solve this. The second method is going to be very helpful when you see fractions and denominators in your equation. But both ways work. It's your choice how you want to solve it, but one way may be better than the other depending on whatever you want, how to solve it. So, first method. Okay, method 1. Our goal is to solve for x, so we have to get rid of every number not attached with the x. So I have a 4, a 3, a 2, and a minus 1. So you always clear the pieces not with the x. So if I said this in words, it's really x times 3 minus 1 divided by 2 plus 4. So to solve, you work backwards. So the last number I came across was the 4, so that's the first thing I get rid of. Since it was plus 4, I minus 4 from each side. That's 5. Now I'm left with 3x minus 1 over 2 equals 5. And if I say this, x times 3 minus 1 divided by 2 equals 5, the last thing I said was dividing by 2. So to get rid of the 2, I multiply each side by 2. That clears out the 2's. So 3x minus 1 equals 10. And then I got a basic two-step equation. I add 1 to each side. So 3x equals 11. And then I divide by 3. And you'll get x equals 11 over 3. And you can substitute it in and check. You will get your answer. I'm not going to worry about the check. So that's method 1. And that's probably the method you've seen a lot. I did go over it in class 2. Method 2. I'm going to write the same equation again. And I want to solve for x. So we know it's going to be 11 thirds. So whenever you have a fraction, to clear the fraction, you can always do this. You multiply all sides by your LCM, your least common multiple. So in this case, if I have a least common multiple, I basically want the smallest number that goes into each of the fractions. In this case, since it's only a 2 in the fraction, I'm going to clear it by 2. And you'll see one where there's more than one number later on in the fraction. So in this case, I'm going to multiply everything by 2. All sides by 2. So really, when I multiply by 2, I'm just going to distribute the 2 to each piece in the equation. So I'm going to multiply everything by 2. So when I do that, it becomes 8 plus, and then 2. The 2 here cancels with the 2 in the denominator, so now I'm just left with 3x minus 1, and then 2 times 9 is 18. So when you multiply by the LCM, it clears out the fractions, and now you're just left with an equation without the fractions. Now I want to solve this. To solve, I'm going to first clean up the mess. I'm going to combine like terms. Nothing combines with the x pieces. 8 and negative 1 is 7. So now I have 3x plus 7 equals 18. And now to solve, I minus 7 from each side. 3x equals 11. And then I divide by 3. And you'll get x equals 11 thirds. So the trickiest part is knowing what your LCM is and then distributing it to each part. But when you do that, it just becomes no fractions, and it just, in my opinion, makes it a little easier to solve. So you get the same answers both ways. It's up to you which method. I don't have a preference unless there's several fractions. Then you might want to, instead of work with all the fractions. One fraction is not a big deal, but when you see 2 or 3, you may want to use the second method. So now we're going to do one that has multiple fractions. So next one, we have 7 over 60 equals 5 over 24w plus 11 over 12. I want to solve for w. So we could use like method 1 here, minus the 11/12s, but then we have to do all the fractions, common denominator, all that stuff. And it's a little bit of work. You can use your calculator too. But I'm going to use the second way, find the LCM. So for my fractions of 60, 24, and 12, the smallest number that each piece goes into is 120. 12 goes into 60, 24 doesn't go into 60. So if I did 60 double, that's 120. 12 goes into 120, 24 goes into 120 as well. So find the LCM. I'm not going to worry about that too much, how to find it. There's lots of ways. You can just write out each number and find the overlap. It's not going to be a super trick question with that. It'll be something nice where you can find it. So all I'm going to do is multiply everything by 120. So I'm just going to rewrite this out again. So I'm going to multiply everything by 120. So I have to distribute the 120 to each piece. And you must do it to everything. So 120 over 60 is really just 2. So now it just becomes 2 times 7. That's 14. Or you could just do 120 times 7 over 60 on your calculator. You get 14. 120 over 24 is 5. So really it becomes 5 times 5w. That's 25w. And then 120 divided by 12 is 10, so 10 times 11 is 110. So when I multiply 120 by each piece, it just simplifies to 14 equals 25w plus 110 when you clear out the denominators. So now I just solved this two-step equation like normal. I'm going to get rid of the 110 first by minusing it. 14 minus 110 is negative 96 equals 25w, and then the divide by 25, and you'll get negative 96 over 25 equals w, and that's your answer. So when you have fractions in your denominator, this is a quicker method when it's more than one. Find your LCM, multiply each piece by it, and then you're left without the fractions and just solve them normally. If you don't, you can work with the fractions, but you could, it makes it a little more tedious. So that finishes up section 1-2, solving linear equations. Now we're going to get into our next section, which is 1-3, and this is variables on both sides. So variables on both sides. So basically you'll have an x piece on one side and an x piece on the other, a letter on both sides of the equation. And we're going to use our same rules like before. So first example, let's say we have 100 z minus 0.2 equals negative 10 5z plus 0.8. So I want to solve for z. Notice I have a z on each side. So whenever I have variables on both sides, I have to follow my order or operations. So I want to clear the parentheses and then follow the order of operations. Clear the parentheses, combine like terms, and then solve like normal. So in this case, since I have the parentheses, I take the piece on the outside, I distribute it to each part on the inside. So 100 times z is 100z, and then 100 times negative 0.2. I'll do that on the calculator. 100 times negative 0.2 gives me negative 20 equals negative 10 times 5z, that's negative 50z, and then negative 10 times 0.8. Do that on the calculator. We get negative 8. So now I have 100z minus 20 equals negative 50z minus 8. Now I want to solve. It doesn't matter really which variable piece you get rid of, but my rule of thumb is you get rid of the smaller variable piece. This way you work with a positive number at the end. Then you don't have to divide by a negative. So in this case I have 100, negative 50, of the two which is smaller, negative 50. So the opposite of minus 50z is plus 50z. So I add 50z to each side. This gives me 150z minus 20 equals negative 8. Now this is just a basic two-step equation. Solve for z, add 20 to each side. Negative 8 plus 20 is 12. So now 150z equals 12. Divide by 150. And you get z equals 12 over 150. And let's see if I can simplify that. 12 divided by 150 is 0.08. Or as a fraction, I can just hit the second arrow, and that's 2 over 25. So either one. So 0.08 or 2 over 25. It doesn't matter how you write it as long as it matches. It might say write it as a decimal, write it as a fraction. It's up to you. You can even say 12 over 150 is acceptable, but this isn't simplified. Usually you want to simplify your answer completely. Okay, so next one. We're now going to talk about equations that have infinite solutions or no solutions. So sometimes you might not just get one answer. Sometimes you might get an unlimited amount of answers or no answer that work, and that's okay. So if I have t minus 27 equals negative parentheses 27 minus t, and I want to solve for t. I'm going to clear the parentheses. So left side I'm fine, nothing there. This minus really is like an invisible minus 1, so I'm doing minus 1 to each piece. So negative 1 times 27 is negative 27, and negative 1 times negative 1t is a positive 1t. And now to finish solving, I'm going to get rid of one of the t's. Since they're both 1, it doesn't really matter. I'm just going to take away t. You'll see that this is an identity. Both sides match exactly. So now I have negative 27 equals negative 27. This is always true. So whenever you have an identity, something that matches exactly, this is infinite solutions. So any answer you substitute in for t will work. So any answer works in this since it's an identity. So I could use 1,000, negative 1,000, any number. Infinite solutions. There are also cases where you'll get no solution. So the next one you'll see is going to be one with no solution. So 16 parentheses 4 minus 3m equals 96 parentheses negative m over 2 plus 1. So now I'm going to solve. So I'm going to clear the parentheses first. So I'm going to distribute, and I'll show the arrows too. 16 times 4 is 64. 16 times negative 3 is negative 48 with the m. Other side, 96 times negative m over 2. 96 divided by 2 is 48, so this is just negative 48m. And 96 times positive 1 is positive 96. Now I want to solve. Both variable pieces are exactly this, have the same coefficient out in front and minus 48. So it doesn't matter which one you'll get rid of. I'll just add this 48m to each side. They're going to cancel out anyway. So now I'm left with 64 equals 96. Notice now this is very similar to the other one, except this is never true. Whenever you get something that doesn't match after you eliminate the variables, never true, this means no solution. So there's no answer that will ever work for m to make this true. There's no number I can substitute in, so it will never have an answer. So infinite solutions, no solution. Basically, the variable pieces cancel out and you're just left with either an identity or something that doesn't equal each other. One more example on this. Let's say I have two fractions equal to each other. Q plus 1 over 2 equals q minus 1 divided by 3. And I want to solve for q. So whenever you have an equation with a fraction, like so, I can cross multiply. I can crisscross. You could also multiply through by your LCM of 6 and get rid of each piece, but in this case I can, when I just have two fractions equal to each other, I'll cross multiply. So this just becomes 3 parentheses q plus 1, 3 times q plus 1 equals 2 times quantity q minus 1. Now I just solve for q. Distribute. 3q plus 3 equals 2q. 2 times negative 1 is negative 2. Now I have to eliminate one of the variable pieces. 2 is smaller than 3, so I'm going to get rid of the 2. Subtract 2q from each side. Q plus 3 equals negative 2. Solve for q, I minus 3 from each side. And you'll get q equals negative 5. Negative 2 minus 3 is negative 5. And you could substitute back in to check. Just be careful when you cross multiply your denominator to see. Remember, your denominator can never be 0, but since there's no variable in the denominator, you don't have to worry about this. But say the q was in the denominator and you got that answer, it couldn't be it. You got to make sure that your denominator is never equal to 0 for whatever answer you get. So that concludes 1-3 variables on both sides. So remember, sometimes you can get infinite solutions, no solution, or just a single solution. And follow your steps. Clear the parentheses, combine like terms, and then solve normally. Last section is going to be our inequalities. So hold on, let me get another piece of paper. So 1-5. Here we go. Inequalities in one variable. Okay, so we're just going to review our inequality symbols for graphing and stuff. You will see this a lot when you do get to Algebra 2 again. So we're just reviewing it. So our first symbol kind of looks like an L, sideways L. This is our less than symbol. And when you graph it, it will be an open dot to the left on a number line. Open dot to the left. The next symbol is your greater than. This is an open dot going to the right. All numbers greater than that, but not included. Next symbol is less than or equal to. That includes the number. So it's going to be a closed dot to the left. And then the last one is the greater than or equal to symbol. And that's an closed dot to the right. So those are your symbols. And then one important rule with inequalities, and you're going to need to apply this whenever you multiply or divide, D-I-V-I-D-E, by a negative number, you must flip the inequality sign around. So whenever you multiply or divide by a negative number, you flip the inequality sign around to keep it true. Otherwise, it won't. It's not going to match your solution at the very end. And we're not going to go to details of derivation. We talked about that in the past. Only when you multiply, divide, adding or subtracting a negative, nothing changes. Only when you multiply or divide, the inequality sign flips around. So we'll see a couple examples that involve this. Okay, so the first one we're going to talk about is negative 3 parentheses 2x plus 2 is less than 10. So we want to solve for x. So I'm going to clear the parentheses. I'm going to distribute the outside number to each piece on the inside. So it becomes negative 6x minus 6 less than 10. You can also write negative 6x plus negative 6. Not going to affect it. Now I solve. So first thing I'm going to do, I'm going to add 6 to each side. Negative 6x. The inequality sign does not change, so I leave it alone because I didn't multiply or divide by a negative. Final step, get rid of the negative 6. I divide by it. Since I'm dividing by a negative, the inequality sign flips around. So now it becomes x greater than negative 16 over 6. And that's my answer. And I could simplify this to x greater than negative 8 over 3. Both are correct. Negative 8 over 3 is the simplified version of negative 16 over 6. And you could also write it as a decimal, I guess. It's not going to be a repeating, it's going to be a repeating number. So 8/3 negative as a decimal is negative 2.6 repeating. Or we could just say x greater than negative 2.6 repeating. Both are acceptable. Okay, next one. We're going to do one with an equality with a variable on both sides. So 2x minus 5 is less than 5x minus 22. So in this case, for my x species, 2 is smaller than 5, so I'm going to get rid of the 2x by minusing it from each side. So now I have negative 5 less than 3x minus 22. Solve for x. I'm going to add 22 to each side. Negative 5 plus 22 is 17. Inequality sign stays the same since I didn't multiply or divide by a negative. And then I have 3x. Last step, I divide by 3. Inequality sign again doesn't change because I didn't divide by a negative. So now I have 17 over 3 is less than x. When I write my inequality, I want to put my variable piece first. So I can rewrite this by writing the x piece first. When I write the x piece first, it's x. Notice it's eating the x, the inequality, so it's going to eat the x when I rewrite it. So it's x greater than 17/3. So when you rewrite it, just flip the two pieces around, and then whatever way it's eating the piece, whichever one it is, that's the way it goes here. So 17/3 less than x is really the same as x greater than 17 over 3. Don't say x is less than 17 over 3. For example, if I substituted in 100, 17/3 is less than 100. So you got to make sure when you write the variable part first in your inequality that you flip the symbol around to match it. Everything flips. And we can leave that. That's our answer. Okay, two more. Now we talked before with variables on both sides. This is very similar. Now we can also have inequalities that could have no solution or infinite solutions. So next one we have -2. 4x minus 2 is greater than, or sorry, less than -8x plus 4. Okay, solve for x. I'm going to distribute the -2 to each piece. So -8x, -2 times -2 is positive 4, less than -8x plus 4. Notice both sides match. This is an identity, but I'm going to just simplify it further. Since both x pieces have a -8, doesn't matter which one you get rid of. I'm just going to add 8x to each side. Now I'm left with 4 less than 4. Very similar to the thing. However, 4 less than 4, this is not true. 4 equals 4 would be true. 4 is not less than 4. 4 could be less than or equal to 4, but 4 is not less than 4. So since this is not true, this will be no solution. So no answer works. So I can't take any value and substitute it in to make this true. So you got to be careful here with the inequality. Just because I get 4 on each side, you might think, oh, every answer works. No, because of the inequality, 4 less than 4, that's not true. If I had an equal sign there, then it'd be true, and then I could say infinite. So this is no solution. And last one we'll look at, -6x minus 5 is less than -3 parentheses 2x plus 1. I'm going to distribute the -3 to each piece on the right side. -6x minus 5 less than -3 times 2x is -6x. -3 times 1 is -3. Again, notice the x pieces have the same coefficient out in front. So I'm going to get rid of either one since they both match. I'm just going to do the opposite. -6x, I'm going to add 6x to each side. So now I'm left with -5 less than -3. -5 less than -3. That's always true. So this would be an infinite solutions. So basically, we say all real numbers instead of infinite solutions, all real numbers. So if every answer works, it's infinite, we call it all real numbers. That means every single number works. That's how you solve inequalities with variables on both sides. So again, we reviewed how to solve equations, basic two-step equations, variables on both sides, and inequalities in one variable. So then you'll now apply it to the assignment that I'll be giving you. This is Mr. Holmes signing out. Again, please make sure you know how to solve equations and inequalities. It is very, very important. You're going to continue to see it out throughout your math courses in high school and college. Again, Mr. Holmes signing out. Have a great rest of the day. Take care. Bye-bye.